All right, so the next thing we're going to start is bearing. The next topic is bearing. Here it is. A bearing is the angle in degrees measured clockwise from north. A bearing is the angle in degrees measured clockwise from north. That's a bearing. In other words, bearing is basically used to give direction. And you give direction based on where something is clockwise from north. So bearing is the angle in degrees measured clockwise from north. A bearing is usually 3 digits. So a bearing of 45 degrees is written as 045 degrees. So bearing is usually 3 digits. For bearing, we don't normally give bearing as a decimal. So you don't say 45.5 degrees. It's either 46 or 44 degrees. So you don't normally, for a bearing, you don't normally use what? Decimals. Now, a bearing question usually involves solving a triangle. And guys, by now, everybody should know that to solve a right angle triangle, the tools are Pythagoras theorem and the trig ratio. And to solve a non-right angle triangle, your tools are sine rule and the cosine rule. So Pythagoras theorem and the trig ratios are used to solve a right angle triangle. Sine rule and cosine rule are used to solve a non-right angle triangle. This knowledge is important. And the reason this knowledge is important is because when you deal with bearing, you're going to deal with north, south, east, and west lines. And 2 north-south lines are parallel and 2 east-west lines are parallel. So it's important that we revise our knowledge or review our knowledge of parallel lines cut by a transversal. So of course, in this diagram, we have 2 parallel lines. The parallel lines have arrows on them and they're going in the same direction. Now, the straight line that connects or cuts across 2 or more parallel lines is called a transversal. So guys, you need to remember that when parallel lines are cut by a transversal, the angles around each intersection in the same position are equal and they are called corresponding angles. So from my diagram, A is equal to E, they are corresponding angles. In the diagram, A is the top right angle. At the top intersection, A is the top right angle. At the bottom intersection, E is also the top right angle. A and E are corresponding angles because around each intersection, they are in the same position. A is equal to E, they are corresponding angles. B is equal to F, B is equal to H, and C is equal to G. Those are corresponding angles. Guys, the angles between the parallel lines are called interior angles. So looking at our diagram, B, C, E, and H are interior angles. B, C, E, and H are interior angles. Now, 2 interior angles. So what you have here with the interior angles, you have the interior angles which are to the right of the transversal, and you have the interior angles which are to the left of the transversal. Guys, now 2 interior angles on the same side of the transversal add up to 180 degrees. They are called co-interior angles. So B plus E is equal to 180 degrees. And C plus H is equal to 180 degrees. They are called co-interior angles. The interior angles are the angles between the parallel lines, B, C, E, and H. So we have what? So this is what I was talking to you about, co-interior angles. This says Angles, co-interior angles are supplementary. They add up to 180 degrees. And co-interior angles are interior angles on the same side of the transversal. So B and E, C and H, they add up to 180 degrees. They are co-interior angles. Up here, we have alternate angles. Now, alternate angles are sometimes called Z angles, and alternate angles are equal. Alternate angles are interior angles on either side of the transversal at opposite intersections. Alternate angles are sometimes called Z angles because if you use the parallel lines and the transversal to write a Z, the angles which are formed are the alternate angles. So the angles formed here are what? B and H. The angles formed here are what? C and E. So what? B and H are alternate angles. C and E are alternate angles. And alternate angles are equal. So whenever you have parallel lines cut by a transversal, you must remember corresponding angles. You must remember co-interior angles, and you must remember alternate angles. It's necessary to have this knowledge available to you when you're doing bearing, because two north-south lines are parallel and two east-west lines are also parallel. So let's talk about the four cardinal directions. The four cardinal directions are north, south, east, and west. The four cardinal directions are north, south, east, and west. East is 90 degrees to the right of north. South is 180 degrees, or south is opposite to north. It's 180 degrees to the right of north. West is 270 degrees to the right of north, or in a clockwise direction from north, that's clockwise. So we have north, south, east, and west. The angle between north and east is 90 degrees. The angle between north and south is 180 degrees. The angle between north and west is 270 degrees. All right. And the four cardinal directions, they're at right angles to each other. North is at right angles to east. East is at right angles to south. South is at right angles to west. West is at right angles to north. These are the four cardinal directions: north, south, east, and west. East is to the right of north. West is to the left of north. So east is 90 degrees clockwise from north. So a bearing between north and east is less than 90 degrees. South is 180 degrees clockwise from north. A bearing between east and south is more than 90 but less than 180. West is 270 degrees clockwise of north. A bearing between south and west is more than 180 but less than 270. A bearing between west and north is more than 270 but less than 360. Guys, I said this to you earlier, that bearing is actually giving direction clockwise from north. A bearing of a point in between north and east. The bearing, which is an angle, must be between somewhere between what, 0 and 90. So this would be the bearing. Let me get red, probably more visible. The angle here in red would be the bearing, because bearing is an angle. That would be the bearing of this point here. Let us say A. Bearing, the angle is measured clockwise from north. If it is, let us say this is the point B. The bearing is measured clockwise from north. This angle here would be what? more than what? 90, but less than what? 360. Let's say a point in this direction, let us say C. Bearing is measured clockwise from north. You come around, pass east, pass south. That bearing would be between what? 180 and 270. If the point is in this direction, let us say that this is B. The bearing of B would be more than 90, more than 80, more than 270, but less than what? 360 degrees. Bearing is giving direction using angles, and the angles are measured clockwise from north. We'll see that in action more. All right. This said considerations when drawing and interpreting bearing diagrams. Considerations when drawing and interpreting bearing diagram. Here it is. A straight line connecting the 2 points. A straight line connects the 2 points. North, south, east, west line is drawn at the point where the bearing is taken from. Let's put the word from. So if I'm talking about the bearing between 2 points, you need to have a straight line connecting those 2 points. The point where you're taking the bearing from, you're going to draw a north-south line at that point. Now, an arc, which represents the angle, is drawn clockwise from north to the line connecting the 2 points. So, for example, let's say I have 2 points here, A and B. This is the line connecting the 2 points. All right. Now, let us say I'm taking my bearing from B. I'm taking my bearing from B. Anywhere you're taking the bearing from, at that point, you're going to draw your north, south, east, west line. So at B, I draw my north, south line. This is north, this is south. Now, the angle that represents the bearing of A from B must start at north and come around to the line connecting the 2 points. That angle there, guys, which is more than 180, but less than what? 270. That angle, whatever this angle is, let us say it's 215 degrees. That angle there, guys, is the bearing of what? A from B. How do I know it's from B? Because you always draw the north-south line wherever you are taking the bearing from. All right. So that's all that consideration bit is saying. All right, so let's have a look at a little example.